The next three reactions that we will learn are the transformation of alcohols into the corresponding alkyl halide. For instance, you can transform terbutanol into terbutyl bromide, or you can transform, let's say, ethanol into chloroethane. So the only catch is that it depends on the kind of alcohol that you have at hand, the method that you will use. If you want to transform a tertiary alcohol, like the one I am circling there, in that case, you can use directly an acid. If you want to make the chloride, of course, you will use hydrochloric acid. If you want to make the bromide, you will use HBr. But if you want to make a secondary alcohol or a primary alcohol into the corresponding halide, in that case, the reaction with acid doesn't work, or it doesn't work so well. So that's why we have an alternative reagent. And if you want to make the chloride, in that case, you will use SOCl2. We call that thionyl chloride. And if you want to make the bromide, in that case, you will use PBr3, phosphorus tribromide. So let's see some examples of that. So here I have, in order to make this tertiary alcohol into the corresponding bromide or chloride, what should be the reagent that I have to use? Well, the reagent will be, for the top reaction, it will be HBr. And then for the reaction to transform the terbutanol into the corresponding chloride, there, of course, I will have to use HCl. How about if I want to transform ethanol into the corresponding chloride? Well, in that case, because this is a primary alcohol, I cannot use directly I cannot simply use HCl. I need to use SOCl2. And actually, in this method, you will use SOCl2 and pyridine. Pyridine is a base, so the purpose of using pyridine is to capture the hydrochloric acid that will be produced as a side product in this reaction. If you want to make the secondary alcohol that I have here into the corresponding bromide, well, because it's secondary and not tertiary, I cannot use HBr. So the reagent that I will have to use will be PBr3. All right, so that is the deal there with the transformation of alcohols, depending whether they are primary, secondary, or tertiary. I will use different reagents to make the corresponding halide. Well, why is that the tertiary works well with HBr or HCl and not the secondary or the primary? Well, all the time, the explanation can be, you can give the explanation based on the mechanism of the reaction. So let's study this here. See, if I have a tertiary alcohol like this one, and if I react that with HBr, you may expect that the pair of electrons will capture a proton, then the bromide will leave, so I will have a Br minus, and when I have protonation of the OH of the alcohol, here I have essentially in this region here, I have a water molecule, right? And the water is very stable, so I can have this group just graciously departing. So I will have a water molecule that will leave. And what is going to leave behind? Well, because the water is leaving with a pair of electrons here, so what I will leave behind will be a carbocation. And what kind of carbocation is this? Primary, secondary, tertiary? Well, this is tertiary. And you know that tertiary carbocations are relatively stable. So that's why the reaction will work. And then I will have the bromide will come back, Br minus, will react with a positive charge there, and the bromine will get attached there. And that's the way I will get my terabutyl bromide. So let's say that if I was trying to do this similar thing, but with methanol. That is not such a great idea, right? Because if I use methanol, the initial steps may work okay, right? I can have a pair of electrons capturing a proton. I will form my water molecule that is still hanging there in the alcohol. But then now when the water molecule tries to leave, so then I will have to form a methyl carbocation. And you know that methyl carbocations are not that stable, right? So that is the reason why instead of using HCl for a primary or for a secondary alcohol, we prefer to use thionyl chloride and pyridine. This is the structure of pyridine. So because the nitrogen has a lone pair of electrons, that will help me to capture the hydrochloric acid that will be produced in the reaction. Then before we go, let's analyze how do we perform the reaction to form the bromide. Let's say that if I have a secondary bromide, well, secondary bromide, of course, I have 1, 2, 3. So this is this is 3-pentanol, right? 3-pentanol. I cannot use HBr because if I was using HBr, when the water molecule leaves, it will form a secondary carbocation, and secondary carbocations are not very stable. That is the reason why we use PBr3 instead. And that will give me the successful reaction to form the bromide. The mechanism for the reaction with PBr3 or with SOCl2, we will get to discuss that later in some future chapters. So before we go, how could you prepare this particular chloride starting from this alcohol? I need to look at what kind of substitution I have here. This is a tertiary alcohol. Because it's tertiary alcohol, I can use HCl. How about in the second reaction? Here I have a secondary alcohol, right? This is secondary alcohol. So I cannot use HCl. So what will be the reagent of choice? It will be SOCl2 and pyridine. All right, so I will stop here and we will continue later.